happening, everybody? Welcome to Tech Talk number 11. We're not meshing around or something.
Yes, we are.
Yeah, we're gonna mesh around.
We are gonna mesh around.
Yeah. It's good for the communication in this world, right? So yeah. So I guess we are gonna be meshing around today. So Ryan Bowman, Brian East from Connect Us, the dynamic data duo or something like that, right? Or I guess bearded duo. Brian's
bearded brothers.
Yeah, Brian's got the beard.
Different mothers.
I just, I'll take credit for the hair. He's got the beard game, so it's a good fine mix. So certainly welcome back to Tech Talk, where we attempt to take a lot of these crazy technical items that we work with through the cellular world and kind of simplify them down, break them down, and share and show how they work in the marketplace and in the industry, and how we can kind of all play well together and help customers by providing these solutions. So from our meshing puns, today we're going to be talking about mesh networks. And when I say we, I use that very lightly because it's more like Brian's going to be talking about mesh networks. I'm going to be learning about mesh networks. So with that all said, Brian.
Okay, I will take it away. What is a mesh network? That's the winning question for that, the latest Jeopardy, by the way. So a mesh network is a type of computer network where you've got multiple devices throughout the building, or sometimes multiple buildings, or sometimes outdoors, known as nodes. And they're going to be positioned all over the place. They're interconnected to provide reliable and efficient communication. So in a mesh network, each node serves as a relay for data transmission. If you see in the little graphic there, it's a 3D representation, but in reality, it is going to be a 3D topography as well. They all connect to each other, and there's multiple paths for information to go from one spot to another. This is really, really important. This distributed architecture eliminates the need for a couple of things. One, a central router. So you don't need that hub and spoke topography, and you don't need access points. It enables those multiple paths. And this does a couple of things. It enhances network resilience and coverage. So in a mesh network, each node cooperates with the other nodes to create a self-configuring and self-healing network. So if one of your nodes goes down, or the communication is disrupted from one of the connections, the network can automatically reroute this data through alternate paths. It maintains connectivity. This decentralized nature of mesh networks make them particularly useful in scenarios where, like traditional network infrastructures could be unreliable, such as like large-scale deployments, outdoor environments, areas with limited infrastructure. So mesh networks, where are they used? They're commonly used in wireless communication systems. You've got wireless LAN, what you would think of as Wi-Fi, IoT situations, wireless sensor networks. Say if you're in a restaurant, you've got lots of sensors, or in a SCADA environment for industrial usage. And it can also be employed most often for expanding Wi-Fi coverage in homes. So if you've got a giant, rural sprawling home, and your office is in the second floor, far northwest corner, the kitchen or the attached garage, where your spouse's office is in, the first floor southeast corner. You can use this mesh network. The kids are up there playing, streaming video games, whatever the case may be. You can walk throughout the house and keep that same internet connection. This often is used in office spaces by using multiple interconnected access points. So, a couple of weeks ago, we talked about LoRaWAN. LoRaWAN is a perfect example of a mesh. So also, Ryan, these hospital projects that we do,
Yep.
we've deployed these mesh networks, and it allows nurses that are connected, with their smart devices, their tablets or their phones, doctors as well. They're carrying around their laptops. They can go throughout the entire floor, multiple floors. You've got 19 floors high. They can go down different floors, and in a hospital complex, you've got multiple buildings. We do that as well. So they're walking from one building to the next, from floor 1 of building A, and then they go up to floor 19 of building B, and then on to floor 15 of building C. They're on the same network the entire time. The opportunities for this is endless. So, and here's a perfect example in kind of a smart city environment. So let's sum it up, right? These mesh networks offer robustness, so you can go take care of everything around. Scalability, so as you expand, there's not a whole lot of extra configuration that needs to happen. And then it's also flexibility that's brought in here. So you have needs that say this office was empty before, but now you've got a lot of people going, filling up this office. There's new business in there. You put some nodes over there. And then finally, and this is really, in my opinion, the most important part, is that fault tolerance aspect, where if one node goes down, you're not screwed over. Yeah. So that is mesh.
No meshing around.
No meshing around. So we do have one low tech thing of the day.
Low tech thing of the day. Yeah. Before you get to the low tech thing of the day, I did want to just chime in there that I echo everything you said about, especially the fault tolerance, right? I think that's just such a key component to it all. If you have one of those sensors or beacons or whatever you're using, depending on the technology that goes down, that you don't lose your entire network. You lose that communication path because of that. You just simply lose that one sensor for that one thing, which I think is pretty awesome. I know in the IoT standpoint and where I've been previously with using different technology on IoT solutions, that is such a huge component to why mesh networks work so well. So thank you. It was awesome.
Yeah, and in some traditional, access point environments, you can have two APs that are kind of close to each other, which is helpful in so much that A, one goes down and you still have the other one, and then B, they both provide, kind of coverage. But those Wi-Fi networks can sometimes interfere with each other, destructive interference. If they're on the same wavelength, then you've got collisions happening, and it compromises the speed of your connection. Sure. With mesh networks, that goes away.
They play much better in the sandbox.
Yep, they're friends. They're friends.
Cool. So what's the non-tech of the week?
This here is a dog, as you can see, but it also is a paperweight. Very heavy. Finally, it's a walnut cracker.
That's awesome. There we go. The ingenuity right there.
Yeah, and also if you have siblings and you want to mess with them, just, hey, put your finger in here. Check it out.
Nice. Here you go.
We did that. This is an old piece. Was handed down from my great grandparents, and a lot of people have been hurt by that. A lot of crying.
And then comes wisdom, and I bet it doesn't happen again.
That's right.
Oh, this is how we learn.
Everyone can drink lava once.
Yes. Yeah, I don't think I want to learn that one. So
yeah, not a whole lot of wisdom.
I'll take everyone's word for that.
Yeah. Check it out, guys. Hold my beer.
Nice.
All right, guys. Well, that's all I've got on Mesh Network and almond crackers.
Yeah, that's pretty cool. So until next time, continue to check us out on social media, LinkedIn, see what we're doing in the community and with our partners and just in technology in general. So we're excited to connect us where we can partner with everyone and help all of your technical needs. So thank you so much and have an amazing day.
Y'all be well.
See you.